So today we're going to move on and we're going to talk about how to reverse engineer ellipse equations from various pieces of information. So this is still the same section, which is 10.4. Sorry, 9.4, thank you. Geometry is in chapter 10 right now, so that's why. All right. So what we're going to do now is very much like what we did with parabolas, where they gave us the focus, or they gave us the directrix and the center, and we had to come up with the equation. But now we're going to do it for ellipses. So for example, they're going to give us something like the center is 0, 0. One vertex is going to be 6, 0. And a co-vertex is going to be 0, 4. And they want us to find the equation. And remember how easy you guys found these with parabolas? Ellipses are going to be just as easy, okay, in terms of difficulty. They're a little more work, but the difference is, the key is the same as it was with parabolas. What was the key to making the parabola ones easy? The picture. Draw the picture. Same thing here. You need to draw the picture. So you make yourself a quick little sketch, and our vertices are going to be, well, we have one vertex at 6, 0. So if one vertex is at 6, 0 and the center is at 0, 0, where must the other vertex be? Negative 6, 0. Anything hard about that? We have a covertex at 0, 4. Where must the other covertex be? 0, negative 4. And so our ellipse is going something like this. Which way is it being stretched more? Although it's not real easy to tell, but from the numbers we see it's being stretched more in the x direction. So is that going to be x squared over a squared or y squared over a squared? Good. So write down your basic equation, x squared over a squared plus y squared over b squared equals 1, because remember a is the bigger number, and in this case it needs to go with x, because x is the bigger direction. So the question now is, what are a and b? We need to fill those in. So do we know what a is already? Yeah, how far left and right do we go in the long direction? 6. So that means that this is now 6 squared. How do we know b? Yeah, how far do we go in the y direction, the short direction? That's going to be 4 squared. So our final equation then is x squared over 36 plus y squared over 16 equals 1. Easy enough? Oh. Okay. All right. The next thing we need to take a look at is, what if they change this up a little bit? It's really easy if they give us the vertex and the covertex, because the vertex is really telling us what A is, right? And the covertex is really telling us what B is. But they don't have to tell us A and B. Sometimes they're going to tell us one or the other, but not both, but they'll give us another piece of information along with it. So for example, they may give us one with center at 0, 0. And they may give us a vertex at negative 8, 0. And they may give us a focus at 4, 0. And we need to find the equation. So again, we're going to draw ourselves a little sketch of this to get an idea of what's going on. So negative 8, 0. Where will the other vertex be then, since this is the center? Positive 8, 0, right? We have a focus at 4, 0. So I'm going to label that with an F. And the other focus then is at negative 4, 0. That's the other F. Which way is this guy being stretched? Left and right or up and down? Yes, sir. What's that? So which way is it being stretched? Left and right. Now, do we know how tall it's going to be? No, we know it's going to be stretched left and right for two reasons. One is that the word vertex was used. That has to be the long direction. The other one is the foci also have to go in the long direction. So we know the long direction. We don't know how far we go in the short direction. So just sketch kind of a generic ellipse that's being stretched left and right. We don't have any idea how far up and down it goes. We just know that up and down will be the short way. Now, given which way it's being stretched, should x go with a or should y go with a? X. So this is going to again be x squared over a squared plus y squared over b squared equals 1. Do we know a? Do we know how far we go each way in the long direction? Yeah, how far? 8. So this is going to become x squared over 64 plus y squared over b squared equals 1. Do we know what b is? Do we know how far we go up and down? No. So they only gave us a this time. They did not give us b. But what did they tell us? The focus, which gives us what letter? C. They gave us a. They gave us c. And we know that c squared is equal to a squared minus b squared. So c is 4. Right? We went 4 each way for the focus. So that's 16 when you square it. Equals a squared minus b squared. And now we can solve for b squared. So minus 64. That's negative 48 equals negative b squared. Divide by negative 1, and that makes b squared equal to what? Now, do I need to keep going? Do I need to find b? No, we really don't need b because we need to fill what in our equation? We're looking for b squared. So since we're looking for b squared and we found it, we're done. All we have to do is plug it in. X squared over 64 plus y squared over 48 equals 1. So that's how you do it when they give you a and c. Guys ready for one more? And then I'll show you the other type of problem we're going to see. Now, what if instead of the vertex and the focus, what if this time they give us the center, 0, 0, the focus, 4, 0, and a co-vertex, sorry, at 0, comma, negative 3. Okay? So again, draw the picture. That's the key. 0, 0, 1, 2, 3, 4, 0, which means the other focus is at negative 4, 0. Okay? Covertex at 0, negative 3, which means the other covertex is where? 0, 3. Which way is this being stretched more? X direction, right? Why? Because that's where the foci are. So, do we know how far it's being stretched? No, so we only know it's got to go past the foci. And this goes back to something I told you early on in the section, which is that conic sections always curve around their foci. So that's why we know it has to go past the foci. So the foci are on the inside of the shape. So is this going to be x squared over a squared or y squared over a squared? So this is going to be another x squared over a squared plus y squared over b squared equals 1. Do we know what a is? No, what do we know? B is what? So x squared over a squared plus y squared over 3 squared, which is 9, equals 1. So we do know that b is 3. And we know that c is going to be 4 because we're going 4 each way to find our foci. So we know that c squared equals a squared minus b squared. So 4 squared equals a squared minus 3 squared. Add 9 to both sides to solve for a squared. And so that's the number that goes here. There's our final equation. Does everybody see how easy that is? But what makes it easy? The picture helps you see what's going on, what your A, B, and C are. Draw the picture. All right, questions about that? So that's one basic type of problem that you're going to have tonight. The other basic type of problem is going to be the graphing stuff like you've been doing. The one difference now is so far we have graphed just circles. We have graphed just parabolas. We have graphed just ellipses. Now what they're going to do is they're going to throw a section at you where they ask you to graph and find all the pertinent information, but they're not going to tell you ahead of time what shape it's going to be. And so your job is to graph it, but in order to graph it, you need to first identify what shape it is so that you can make sure that you put the equation in the right form. So let's talk about how you identify the proper shape. We have three choices so far. We have parabolas, we have circles, we have ellipses. Parabolas are the easiest to identify because what or how many of our variables get squared on parabola equations? 1. It's either x squared or y squared, not both. So if you see one of these equations with an x squared but not a y squared, or vice versa, you know it's a parabola. These both have x squared and y squared. So both variables are squared. So how do you tell whether it's going to be an ellipse or a circle? Well, the idea is that an ellipse is the same thing as a circle, but it's being stretched more in one direction than the other. So the way that you tell the difference is that on circles, the coefficients of x squared and y squared, the numbers attached to them, are equal. For ellipses, the coefficients of x squared and y squared are not equal. So what does that look like? That looks like 2x squared plus 4y squared equals 8. Is that going to be an ellipse or a circle? An ellipse. Why? Because x and y are both squared, first of all, otherwise it would be a parabola, and we see that their coefficients are different. One is 2 and one is 4. Since this is an ellipse, what do we have to do to put it in the right form? Divide by 8. So you would then divide by 8, and you would get x squared over 4 plus y squared over 2 equals 1, and then you would graph it from there. Okay? What if you got one that looked like this? X squared over 12 plus y squared over 12 equals 1. Why a circle? Because they're both x squared and y squared, and their coefficients are equal. They both have a 1/12 attached to them. Right? We're dividing both by 12. So this is actually a circle, even though it's written like an ellipse with the equals 1. It's really a circle. So what do we have to do to graph this? Does this look like the right form for a circle? No, what do we have to get rid of? Yeah, we have to multiply by 12, which gives you x squared plus y squared equals 12. And that will be a circle with a radius of the square root of 12, 2 square root of 3. Okay, so it's important that you identify it, because until you identify it, you have no idea what form you're supposed to write it in. Everybody clear on that? Once you know what it is, you know what form it should be written in, you can put it in that form and then you can graph it. Let's make sure you're clear on the difference between an ellipse and a circle. X squared over 16 plus y over 8 equals 1. Ellipse or circle? Very good. Why is it a parabola? Only one letter is being squared. The other one is not being squared, so this is a parabola. So the first thing I would do is I'd multiply to get rid of the fractions. I'd multiply everything through by 16, which gives us x squared plus 2y. Actually, I should have put a 0 here. Equals 0. And then we have to get the x squared by itself. Remember, it's either x squared equals 4py or y squared equals 4px. So you're going to move this over, and you get x squared equals negative 2y. This is a parabola. So what is our 4p equal to? Negative 2, which makes p equal to negative 1/2, etc. You can graph it from there. Okay? Everybody remember how to do that? So you've got to identify it first, and it's easy to identify. Now, there's one more thing I want to throw in, guys, to be technically correct, and that is it is not enough for both variables to be squared to be a circle or an ellipse. Both variables are squared and added together. Because starting tomorrow, we're going to see x squared minus y squared. So just to say that both variables are squared is not enough. Okay, starting tomorrow, it has to be both variables squared and added together for ellipse or circle. Both variables squared being subtracted is going to give us our hyperbolas. So do you guys see how easy it is to identify what shape it is? You don't really need to do much at all. You just need to take a glance at it and ask yourself a question or two, and you'll know what shape it is. And then you know what form to put it in. Okay, questions? All right, let me give you the homework then.